According to Vedran B, C# is 380 times faster than Python. When you're talking about 380 times, and this was with simmed instructions. Without simmed instructions, C# is still 80 times faster than Python. When you're talking about a performance difference of 1 to 380, you're no longer talking about optimization. You're talking about something that works and something that does not work. To understand why, realize that my cat can run maybe 50 kilometers per hour. Elon Musk's space rockets are about 100 times faster than my cat. That means that the difference between C# and Python is 3 times, 4 times as large as the speed difference between some random mammal and a rocket created for interplanetary flights. It's like it's like the speed difference of a Formula 1 car and your 3-year-old child's play car. Probably more, in fact, if you did the math on it. Now, the reasons for this is because of the garbage collector in Python. You see, Python cannot have multiple threads executing at the same time because the runtime engine that parses Python and executes your Python code is not thread safe. Now, this is an even worse thing than the performance difference. Why is that even worse? Because it means that if you have a machine, a server with, let's say, 32 CPUs or something, and you have a Python web app. Now, for a typical web app, 32 CPUs could easily fork into, if it's accessing database or the file system or doing HTTP invocations, etc., etc. You could easily multiply 32 by 100, so you're up to 3,200 concurrent users before you start seriously experiencing problems, assuming your code isn't really that CPU intensive. So we're up to 30,000 concurrent users on that 32 CPU large server. With Python, that's one user, right? You can only have one user execute the same Python code within the same process at the same time. With C#, you can have 3,200 concurrent users. Now, that comes on top of the fact that Python is like 380 times slower than C#, right? So the CPU time spent within executing the Python code is going to dwarf and become so large that basically you have a single user system. It doesn't matter how many CPUs you throw into your server. You can have a server with 1 million CPUs and you're wasting 999,999 of those CPUs because Python can only execute, one piece of Python at the same time. So Python is fundamentally broken. Python is actually malware. Now, why is that important for you to understand? Well, because there's a 70 to 90% statistical probability of that you now have an AI agent that is built in Python. If you have an AI agent today, then there's 70 to 90% statistical probability of that the AI agent was built in Python. Why? Because Python is the AI programming language. Python wasn't created to allow you to create apps. That was a hack 5 years after Python was invented. Python was invented to be a better shell, a better bash script tool to create small throwaway server scripts doing cron jobs and shit like that. Once you start adding Python code as your backend code behind your web API, then performance will drop 380 times, relatively speaking, compared to if you were using C# code. Python is just broken. There is no other ways to put that. Let me show you a real programming language that actually is an AI programming language. It has almost the same performance traits as C#, and the reasons for that is because it's built in C#. It's basically just a tiny DSL using its own syntax on top of C# that allows you to orchestrate apps together. Much, much easier than you can do with Python. And before I show you what you can do with Hyperlambda, that's the name of the language, please realize that this is the difference between Python and Hyperlambda. So not only is Hyperlambda like 330 times faster than Python or something, but you can get away with 10% of the code base sometimes. Now let me show you Hyperlambda. So here I got the Magic Cloud dashboard. Now I want to show you something. I kind of showed it in the previous video, but I still want to show it here. I want to test the Hyperlambda generator. Now what happens is that I'm entering a workflow which keeps on iterating over and over again, which I can just like throw tasks at the Magic Cloud dashboard, and it's going to generate Hyperlambda code on the fly immediately to solve my problem, execute that code, and return the result of that code. Okay, scrape www.hubspot.com and return all external hyperlinks. 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000, done. 8 seconds. If I wanted to do something like this in Python, we'd be looking at 3 minutes or something. And Magic Cloud generated on the fly dynamic Hyperlambda, executed that Hyperlambda and returned the result of it in 8 seconds. Most of it was probably, LLM time. I mean, probably around, 6 seconds was, OpenAI doing this shit. The Hyperlambda generator itself is capable of generating code in between 1 and 4 seconds. So that's one thing, okay? Return the last 5 logged entries from Magic database sorted by created descending. Load the readme.md file and return its content. Count how many URLs you find at ainiro.io's sitemap. Search DuckDuckGo for Thomas Hansen Hyperlambda and return the first 4 matches. Use the HL generator. Create an HTTP endpoint accepting optional paging arguments that connects to Chinook and returns artist rows. Then execute. When HL is generated, execute it with 510 as paging arcs. When I have generated tools like this, I can just say save it, like I'm gonna do now, right? Okay, stop. I need to say stop to stop the hyperlambda generator, right? Or the test hyperlambda generator workflow. Now create a new module named YouTube and save the above HTTP endpoint as foo.get.hl. You know, I've done so far in this video, we're like 9 minutes in, 4.5 minutes into the video, I've generated 20 hyperlambda snippets. Like this in 1 to 4 seconds. Executing the code is 330 times faster than executing Python code. And I didn't write a single line of code, right? Yes, I want an open API specification for the freaking thing. Generate hyperlambda that uses HTTP GET to invoke my above endpoint with values of 2 rows and 5 offsets. Now I've created a hyperlambda endpoint that I've saved on my server. Then I'm creating hyperlambda code that actually invokes my hyperlambda endpoint. And there you go. I just, you know what, you can fuck around with this for a century and you won't be able to implement it in Python. Have a nice day.